We ended up with a 4 GB file.
What does that mean?
Too big. So that's the surface area, right? So if we differentiate this with respect to t, ds dt is equal to what? 12L times what?
dl over dt.
dl over? dt, correct. dl dt is the rate of change of the length, correct? So we want, how fast is the surface area of the entire cube increasing? So which one do we want here? We want what?
We want ds dt.
That's what we want, correct? We want this when what is true?
When side length is 50.
When solid length is what?
50. 60. No, 50 meters.
50 meters, correct. When L is 50, that's correct. So we have L, so we know that ds dt when L is 50 is equal to 12 times 50 times what?
dl
dl dt. So which one do we still need to solve for?
dl dt.
So now we want dl dt when what is true? When L is what?
50.
50. What equation have we not used yet? That, right?
Yeah.
Correct?
Mm-hmm.
We haven't used that at all. What is, if that's true, what is dv dt?
6.
No. 3L squared times what? dl dt. What is dv dt? What is it?
Oh,
Six.
6. No. Is it 6?
understood what you
It is 6, okay. So 6 is equal to 3 times, well, it's L when L is 50, squared times dl dt. Can we solve for dl dt?
Yeah.
Yeah, dl dt is going to be equal to 6 over 3 times 50 squared, which is equal to 2 over 50 squared. What's the units on that, by the way? It's dl dt, rate of change of length. So what's it going to be?
Meters.
Meters per minute. So where do we plug that in? Right there. So what do you end up with? You end up with ds dt when L equals 50 is equal to 12 times 50 times 2 over what? 50 squared.
It's squared.
So can we simplify that? Sure.
Yeah,
That's going to be
24 over
12 times
50.
2 over what?
50.
50, which is
24 over
24 over 50.
12,
And that's ds dt, that's rate of change of surface area, so it's going to be meters squared per
Minute.
minute. You can simplify it, sure. You do 12 over 25 meters squared per minute, which is the same thing as 0.48. And I don't really like decimals, but you can use it anyway. Meters squared per minute. Correct. If you ever get stuck, so to reiterate, the way I did it right here is a little meandering. I did the differentials because I wrote down what the summary was, and then I just started working with what I knew. I knew that dv dt was this, and then I said to myself, we need dl dt, so how am I going to get that? I'm going to get that from the volume equation. So we solved, we got it this way. Another way to do it would be find the derivatives and then substitute. Or, here's a third method. You could use the original equations and substitute first. Look what we did here. We substituted first. The dangerous thing about substituting too early is you might substitute for something you don't need.
Oh, okay.
I went this way. This way is most comfortable to me because I started with, okay, this is the logical progression right here. And then I went to this. I was like, oh, I'm stuck. dl dt. I need that. So then I got it. I started with what I knew. I went and did the first step. I got to a stopping point, and then I found what I needed. And I kept going. Here are some other ways that make a lot of sense maybe after you've done it this way. So you're not necessarily going to see the cleanest way first, but there are other methods. So let's actually try to differentiate this in terms of t.
Oh yeah, right. Sorry.
Equals pi times. Just put the pi on the outside. We don't need to just ignore. We just ignore it. It's on the outside, right? Well, what do we have to use? The derivative of the first times the second plus the first times the derivative of the second. And we want dv dt when what is true? When the radius is what?
2.5.
Can someone tell me concretely, please? When the radius is what?
2.5.
Pi times 2 times 100 times what? 2.5 times the height of 1/2 plus 100 squared times dh dt. Is that good?
Yeah.
Is that correct?
I think that's what I have.
I think that's right.
Yeah.
Anybody have a value for dh dt? Anybody have a value for dh dt? Anybody?
I do.
What do you got, Strimling?
0.03866.
3.8 what?
66.
How many people agree with that?
I have it like
Okay,
0.2
okay, ready?
minus